All right, so what we're going to do is prove this summation formula by using mathematical induction. So, as always with mathematical induction, we need a base case. And that just means if I use, so in this case, n equals 1. So if we look at the left-hand side, so we're saying that all of the terms that we're trying to add up are of the form 4n minus 3. So on the left-hand side, 4 times 1 minus 3 is 1, which, yes, you notice is the first term of the sum. So that's not a surprise. And on the right side, we have 2 times 1 squared minus 1, which turns out to be 1. So great, we've established a base case. Now we assume, and this might seem repetitive, but we're trying to make a statement about all n, so we just switch up the variable a little bit here. We'll say that 1 plus 5 plus 9 plus any integer of the form 4k minus 3 is equal to 2k squared minus k for some k. Okay, so then the same thing. So any integer of the form 4k minus 3, then the next one, which comes from the k plus first term, will be equal to what? Well, what is it that we want? We want 2 times k plus 1 squared minus k plus 1. Okay, that might be a little tricky, so we'll just have to see how this plays out. So, use what we know first. So we know that all of this, by induction hypothesis, can be replaced with 2k squared minus k. And then we're left with this guy over here, which I'll highlight in a different color here. That guy over there is 4k plus 1. So that's simplified greatly. And now we have 2k squared plus 3k plus 1. Well, that's not what we want. We want that other thing over there. Since it might be hard to get that specific form, all we have to do is really show that these are algebraically equivalent, and then we can call it a day. So this expression is equal to 2 times k squared plus 2k plus 1 minus k minus 1, which is 2k squared plus 4k plus 2 minus k minus 1, which is, I see it, 2k squared plus 3k plus 1. So thus, the summation formula is valid. So that means that this is a true statement, which means whatever value of n I decide to stop at, I have a formula to find the sum of the first n terms. Great. Thanks for watching.